In this video, we're going to take a look at how to solve quadratic log equations. Now, if you look through at these examples, none of them jump out at you as being quadratic, but as we start to solve them, you'll see that they do end up being quadratic equations. So example 2, part A, we're first going to condense the left-hand side to a single log. The way that we do that, remember, with addition, is we condense it to multiplication. So we are going to write this as log of 5x times x minus 1 equals 2. Next, in order to solve, we want to cancel the log, so we're going to use the curly law. In this log, the base is 10 because it's the common log. Remember, when you don't see the base, it's 10. So we're going to do 10 to the second power equals, and I'm going to distribute the 5x into the x minus 1 to begin to simplify our expression. Now we have our quadratic equation, so we're going to evaluate the 10 squared and get all of our variables and numbers on one side of the equal sign. Anytime that you have a squared term and a regular x term, you want to get it equal to 0 and use factoring or quadratic formula to solve. So I'm going to, just because we're more used to it this way, I'm going to put my x squared and my x over on the left, and I will be subtracting the 100 to get it equal to 0. Now I can solve it this way. This one actually does factor. I could use the AC method and factor by grouping, but the simpler method is to divide all of these by 5, because both of my coefficients and my constant are divisible by 5, and of course so is 0. Technically I'm dividing both sides of the equal sign by 5, but of course nothing changes when we divide 0 by 5. Now I'm going to factor what multiplies to negative 20 and adds to negative 1, that middle coefficient, and those would be a positive 4 and a negative 5. Finally, using the zero product property, I'm going to set each binomial equal to 0 and solve, subtracting 4 from both sides and adding 5 to both sides. I have my two answers, either x equals negative 4 or x equals positive 5. Now remember, with a log function, we have a restricted domain, so make sure that you are checking your answers and that they make sense. In this case, if we substitute negative 4 back into our log expressions, both of them will have a negative value that we're supposed to take the log of. So we are going to reject x equals negative 4 as a possibility. You can call that an extraneous solution. And x equals 5 is the only valid solution in this case. When we condense subtraction of logs, we make it a division problem. So the left-hand side stays as is, and the right-hand side we condense to a single log. So we have natural log of x minus 1 times x plus 1. The next step is to recognize that when you have a log equals a log, as long as they're the same base on both sides, you can cancel the logs. So we end up with x plus 5 equals, and I'm going to FOIL out the x minus 1 times the x plus 1, and that gives me x squared minus 1. Hopefully you recognize the conjugates and that there is a shortcut when multiplying those conjugates together. Same thing, we've got an x squared term and an x term, so we want to get those on the same side of the equal sign. Again, I'm going to flip-flop sides so that my x squared is on the left like I'm used to seeing it. I'm subtracting x, and I'm subtracting 5 to get this equal to 0. If you didn't follow me doing that in one step, flip-flop it first. X squared minus 1 equals x plus 5, then move the x and the 5 term over, and you'll see that you'll get the same thing. Factoring again, what multiplies to negative 6 and adds to negative 1. This time we get a positive 2 and a negative 3. So when we use zero product properties, set each term equal to 0 and solve, we get x equals -2 and x equals 3. So when we check our answers by substituting these back into the log expression or the log equation in the first place, if we put -2 in, we can do -2 plus 5 and get a positive value, so it's okay on the left-hand side. But when we substitute it on the right-hand side, we get -2 minus 1, which is a negative, so that's outside the domain of the log function. So we're going to reject that as an extraneous solution. And again, we only have one solution, x equals 3. One more example, and then we are all done. And this one, you'll notice, is a bit more complicated than the last two. We've got that square root in there. So hang with me and we'll get this one solved. Start by condensing the logs again. We've got subtraction of logs. So when we condense that to a single log, we have log base 2 of division. Now what we're going to do is use the curly law to put this in exponential form, get rid of that log. So we have 4x over 1 plus the square root of x equals 2 to the third power, which is 8. So we multiply both sides by 1 plus x in order to get that variable out of the denominator. Next, what I notice is the coefficient on the right-hand side, 8, is divisible by the coefficient on the left-hand side, the 4. So I'm going to divide both sides by 4, and then I'll distribute my 2 through to the parentheses. Now, in order to get that square root of x as a regular x, I'm going to need to square it. Before I do that, I want just the x, or just the square root of x and the coefficient on one side. If I square it right now, I will have to FOIL, and the middle term will still have a square root of x, which is not what I want. So I'm going to subtract 2 from both sides. And then when I square both sides, remember to square the entire side. Do not square the x and the 2 separately. The left-hand side is now a binomial, and when you square a binomial, you need to FOIL. The right-hand side, don't forget to square the 2 as well as the x. Common mistake is to just square that square root and cancel it and leave the 2 as is. On the right-hand side, when we FOIL, if you don't know the shortcut for FOILing perfect square, you take the x and square it, take the 2, multiply it by 2, it's subtraction, so that will stay subtraction. The last term is always adding, because when we take that -2 and square it, it will become positive. Alright, now we're getting somewhere, so we're going to subtract that 4x from both sides to get this equal to 0. And we will try to solve by factoring. So now what we're looking for is what multiplies to 4 and adds to -8. Hopefully you thought about that and came up with nothing, because this one doesn't factor. So we're going to have to use the quadratic formula. So we get x equals opposite of b plus or minus the square root, b squared minus 4 times a times c all over 2a. So we're going to simplify this one. Under the radical, and you guys can grab a calculator and double check me, but I got 48 all over 2. And then the square root of 48 cancels. Then the square root of 48 simplifies. The perfect square factor of 48 is 16. The square root of 16 is 4, and 16 times 3 gives us 48. And then we can divide that 2 into both coefficients in the numerator, and we got our simplified answer of 4 plus or minus 2 square root of 3. In order to see if we have any domain restrictions on this one, 4 plus 2 root 3 will of course be positive. I got a decimal approximation of 7.464 for that one. The one that we have to watch out for is that 4 minus 2 root 3 could possibly be negative. In this case, because the square root of 3 is just a bit smaller than 2, our answer is positive, and I got about 0.536. So both of these, when you double check our original equation, will give us positive values that we're taking the log up. So we have no domain restrictions on this one. We have 2 possible answers. And your you-try questions. Try these to the best of your ability. Go ahead and put in your answers in the quiz, and we will work on them tomorrow if we need lots of help.